This is Team 9 presentation of solar energy. Tanner Stubble will be speaking first, then Kevin Dang, followed by Mitchell Hecker, and Mason Boyd will finish it off. Today we will be covering what is solar energy, why is solar energy important, what are the problems with solar energy, and what does the future of solar energy look like.
Hi, I'm Tanner Stubblefield, and I'll be covering the history of solar energy. Solar energy has been harvested by man in one way or another since our existence simply to stay alive. We used it to our advantage to stay warm and then learned to grow food from it. In one case, it was used to cure the plague of a man's 7th century boredom by simply using a magnifying glass and light that traveled 92.6 million miles to burn ants out of existence. This, centuries later, was taken to another scale by Archimedes and the Greek army when they used it to burn Roman ships in the same fashion 2nd century BC. Solar's advancements stagnated during recorded history of this time for well over a millennia. It eventually came out of stagnation, taking a revolutionary turn during the turn of the 19th century. This is when Lord Kelvin popularized Robert Stirling's engine, which focused and captured the sun's rays to power an engine, which turned to create electricity for the first time in 1816. Its applications towards creating electricity took another stride and advancement in 1873, when it was discovered by Willoughby Smith that the element selenium was photoconductive. This means it was a conductor of electricity that was sensitive to light, conducting more efficiently as the amount of light it was exposed to was increased. We will see how this shaped modern methods of creating electricity on the next slide. Selenium, since the discovery of its properties in 1873, has been used with fluctuating popularity since its beginnings. It was used in the first solar cell using pure selenium coated in gold in 1883, but it was found to have less than 1% efficiency. This naturally led to the search of more efficient materials. And over the years, materials such as silicon mixed with gallium being dipped in lithium led to one of the first silicon cells. It was made by Bell Labs in 1954 and introduced a 6% efficiency. This method of silicon-based cells led to silicon becoming the material of choice, swapping in and out materials and messing with structures of the layers to become more efficient over time. This is where selenium is making a comeback. Selenium vapor is now being applied in layers of new solar panels, showing promise, but seems to have varying results. This is mostly due to sensitivity materials and its reactions at varying high temperatures and varying sunlight wavelengths. Research is still being done to find other uses, but the look for more efficient materials is still on.
Why is solar important? Solar has a great potential in the future and the near future, depending on your outlook on certain variables, to be our leading source of energy production. First of all, solar energy is eco-friendly due to the fact it produces energy without the use of consumption of fossil fuel via combustion. With modern solar energy, though, the energy production does shift back to fossil fuel sources during the off hours of solar production due to the lack of solar storage. Nonetheless, solar still greatly reduces carbon emissions since the majority of energy consumption is during the on hours of solar production. Also, solar, while initially expensive, can have positive profit margins in the long run. For example, a single-family home can produce energy via solar and may have surplus of energy during certain times of the day. With that surplus, they can send energy back into the grid and get paid for it from an energy company. On top of that, the energy supplying the house from the solar energy is completely free. Finally, the outlook for renewable energy is bright due to the fact that energy production via fossil fuel is on decline. Reason for this is because of the potential carbon tax to be introduced into international law to combat global warming. And also, certain governments place aside funds to install solar panels to promote green energy.
Solar energy seems great and has a lot of benefits. So what's the problem with it? And why is it not our primary source of energy? The answer is cost and efficiency. These two problems are what puts solar energy as a topic on the National Academy of Engineering's list of grand challenges in the 21st century. The cost of solar energy has improved dramatically since the use of the first solar panel. However, the installation of these large, bulky solar panels require a lot of heavy equipment and can be very costly. Installation is not the only upfront cost, however. The use of solar energy means purchasing a panel, inverters, batteries, and controllers. This is a lot of equipment, and equipment can break or wear out over time. This increases the maintenance cost. Repairs and cleaning of solar panels require specialists. Another problem is the efficiency of solar energy. The efficiency of solar cells is being studied by researchers every day. Currently, the efficiency of solar panels to provide electricity is around 20 to 25%, as shown in the graph to the right. This efficiency is not very impressive and is actually one of the lowest on the list. The performance of these solar panels decrease as solar cells degrade. This is due to environmental factors such as heat and UV exposure. These factors can also destroy the solar panel by creating cracks and delamination. Despite these major disadvantages, researchers and engineers are working every day to make advancements in an attempt to solve these problems and make solar energy a more practical source of energy.
What changes or advancements are being made in the field of solar energy that might affect the future of the industry? One of the biggest problems facing solar energy is its viability in the marketplace. Though pricing and efficiency are both very important factors to consumers, appearance also plays a notable role in the mind of investors. In fact, research shows people are willing to pay more for a more visually appealing solar panel. These same studies conclude that the most visually appealing solar panels are those that blend to the color of the roofs that they are attached to, darker colored solar panels such as blue or black, solar panels with rounded edges as opposed to square edges, and solar panels with an even surface. Of the above qualities, the most important to consumers was the color of the solar panel. Solar thermal fuels are a unique way to store the sun's energy and release it as heat at a later date. Fuels of particular importance are photoisomerizable molecules, which convert from trans to cis isomers when exposed to certain conditions, such as light, and release heat in the process. An example of this kind of molecule is RGO bis azo, which is high in stability and energy density. The Stirling engine, often powered by its own solar panels attached to the sides of the device, allow the main solar panel to track the movements of the sun throughout the day and calculate the optimal angle for sunlight absorbance. With this information, the Stirling engine then converts the sun's energy to kinetic energy through the use of solar panels to power the solar panel's movements to the correct position and angle for maximum sunlight absorbance. Now that the solar panel is receiving the most sunlight possible, it can generate the maximum amount of energy possible at any given time. This technological innovation increases the overall efficiency of all solar panels and is very important to the future of solar energy, though it still faces problems with cloudy and windy weather, meaning more research needs to be done into the subject.